Hey guys, welcome to chapter 2. We're going to start with 2.1 and this is a quick review of the functions and how do we graph them. We've talked about all this in class, so this is just for you to review. First of all, we said that any function, let me read it in here so we know what it is. It says a relation is a mapping, a pairing of input of values with output values. The input values are named domain, the output values are named range. And a relation is a function provided there is exactly one output for each input. What do you mean by this? We always said your first from the mapping, these are mappings, that's a graph. Your first little bubble here represents your input, also represents your domain, and those are the x values, right? The second bubble right here in the mapping represents either your output, we call that the range, and it's the y values, right? For it to be a function, it says that for every single output, there's only one input, right? So, as you look at this, it says -3 goes to 3, 1 goes to 2, 1 also goes to 1, and 4 goes to 4. We have a second mapping here where it says -3, oh, I didn't make this one. -3 goes to 3, 1 and 3 both point to 1, and 4 points to -2. We talked in class this. As soon as you see two arrows leaving from one x to two different y's, that is not a function. And we'll talk about in a second about the vertical text we talked in class. It doesn't matter if you have the same arrow going to the same y. Okay? Two arrows pointing to the same y, it doesn't matter. You just cannot have one x pointing to two different y's. Okay? Let's go ahead and take this and put it in what we call an order pair or coordinate plane right here. -3 goes to 3. We said this stands for your x. This stands for your y, right? So let's go ahead and do this. X is -3. My y is 3. There's my first dot. 1 goes to 2. So when x is 1, y is 2. When x is 1, y is also 1. And then when x is 4, my y is also 4. This is the first pair. The second one, I would have to graph it on the same one, but we're going to talk about the same place about is this or is not a function. And we talked about the, if you remember, vertical test. I'm going to use a straw for lack of anything. When I put a straw like this, a vertical line that goes through it, if it touches 2 points at the same time, it's not a function. So if you see right here on 1, when x is 1, it touches both 1 and 2. This is not a function. It failed the vertical test. In order for it to work, anytime I move my vertical line, it should only touch 1 point at a time. Let's go ahead and try and graph the second one and see if that's a function or not. Again, for x is -3, this goes to 3. Where x is 1, it goes to 1. When x is 3, it still goes to 1. And when x is 4, my y is -2. If I do the straw line now, and I move it through, it only touches 1 at a time. So this second one is a function. I can put this a function, and this is not a function. The way to know, you cannot have your x repeated. If your x repeats itself like 1 to 2 and 1 to 1, then it's not a function. Y can repeat itself, it doesn't matter. And that's kind of what we talked about. If we look at this coordinate plane, let's talk about it for a second. It has 4 quadrants, quadrant 1, 2, 3, 4. So we start in top right and we move counterclockwise, and depending when you are, your x or y would be either positive or negative. Quadrant 1, both x and y positive, right? These are positive, these are positive. When you move to this realm, your x becomes negative, your y stays positive, right? When we move to quadrant 3, because we're right in here, all of the x is negative, all of the y is negative. And when we move to quadrant 4, my x is positive, what sits on that side, but my y is negative. And that's kind of how we do it. You have a little note on page 68 about the condition for something to be a function, and it really deals with the vertical point. As you look at example 3 on page 68, we talked about it. There's all kind of trees over there. They want to know if that's a function. And in your book, it shows you when you put that line through, it touches at 1.6. And at 1.2, it goes to the same line, which means that is not a function. The next thing we did in here is learning or remembering how to graph a function. And we've done this many, many times, okay? If we have to graph something like y equals x plus 1, there's very simple steps. 1, we build a table. The book tells you one thing, I told you a different thing. In my opinion, we only need 3 values. The book is asking you for 5. You can just do 3. And I can take whatever values I want. I like to keep it simple. 0, 1, and 2 are enough for me. And now we're going back to evaluate the expression when x is something. So what is this? What is y when x is 0? Well, 0 plus 1 is 1. When x is 1, 1 plus 1 is 2. And if x is 2, 2 plus 1 is 3. I can now go ahead and plot this into my coordinate plane. When x is 0, it stays right there. My y is 1. When x is 1, my y is 2. When x is 2, my y is 3. I have 3 dots. I draw a line, and I never forget to put the arrows because it's a continuous line, and we graphed it. On the top of page 68, you have a little steps of how to do this. Step 1, construct a table of values. Step 2, graph enough solutions to see a pattern, and then you connect the dots into a line in this case, okay? We did this, we looked at this. We call this a linear function, and the reason we said in class we call it linear is because it forms a line. A linear function, and we've talked about this before, looks like this. Y equals mx plus b. Remember that? That's from class, and that's from Algebra 1. M stands for slope, which we're going to learn in 2.2. B stands for my y-intercept. And that really means, where does my line touch the y-axis? In our case, it touches at 1. How do I know? Well, my x is 0. That's where my y-intercept is. So wherever your x is 0, this becomes your b, okay? Now, if we're going to write this as a function notation, we said last year too, we can go back in between f of x equals mx plus b. F of x or y are literally the same thing, just different notations, okay? I don't need you to be very confused about that because we don't need to. Now, in order for a function to be linear, x has to have exponent 1, or technically don't have an exponent. The moment that your x has anything else but either nothing or 1 there, it is not a linear function. So if I write this with a 3, that is not a linear function anymore. So that's how you recognize if anything of any function given to you is a linear function. If x has an exponent that's greater than 1, not a linear function. If it doesn't have 1 that's greater than 1, then it is a linear function. If you look at page 70 on the top, that's what we talked about. It makes you determine if one or the other are linears, and then you have to evaluate. Keep in mind, they want you to evaluate if it is or if it's not a linear function. On A, it starts with negative x squared minus 3x plus 5. As soon as you see that x squared, not a linear function. Now, let's go ahead and evaluate that for x equals negative 2, okay? Because that is an important evaluation. Your function is this, f of x equals negative x squared minus 3x plus 5. Please remember, we said anytime we get a number here, we put that in within parentheses. This becomes negative, parentheses, negative 2 to the second power, minus 3, parentheses, negative 2, plus 5. Please do not be tempted to go negative, negative becomes a positive. Remember the order of operations. Exponents get done first. Okay, this is a multiplication. I can put a negative 1 in front of it and go negative 1 times this. But exponents get done first. So this becomes negative 1 times negative 2 to the second power gives me 4, correct? Negative 3 times negative 2 plus 6 plus 5. I can now finish this. This becomes negative 4 plus 11 or 7. Remember, this one was not a linear because we have an x squared. We cannot have anything other than just an x in order for it to be linear. For the second one, g of x, they said g of x is 2x plus 6. Yes, this is a linear. X does not have an exponent, or if it would be there, it would be 1. And all we have to do is find out what is this when x is negative 2. We go g of negative 2 is 2 times negative 2 plus 6, or negative 4 plus 6, which is 2, and that is the value of it, okay? We can write this as f of negative 2, just in case you're wondering. Now, the last thing we have to do is example 6 on page 70, which is a word problem, and it has a lot of words in there. They do give us a formula. They say this. The distance in kilometers that travels, this balloon travels, is D equals 97.8 times K times T. Okay, D is distance, T is hours, right? They traveled a total of 478 hours. The rules governing the state record that the minimum distance covered has to be at least 26,700 kilometers. And they want to know, did they break it or not? On A, it says identify domain and range and determine whether Pickard and Jones set the record. Well, first of all, we're going to do this by using our calculator. This is the first time that we're actually doing this by graphing, and I need you to remember how to do it. We're going to go to y equals, right? It's right there, y equals. And we're going to pretend that this becomes 97.8x. I'm going to go 97.8. If you need to remember, this is your x, right? It's right there. Now, please remember this is real life situation, so we're going to have to tweak with your window. We're going to press on window. And all we're going to do, and mine is already set up, is make my x minimum 0 and my y minimum 0. Okay, the maximum, I would say I would make my x maximum, I don't even know, it doesn't matter to me. I would make it 10,000. This is flying in the air, right? And my y maximum, I would make it, I don't even know, 1,000. Right, I'm going to look like this. Or let's do it the other way around. My x maximum is 1,000. My y minimum is 10,000, because the faster you go, the higher you go, right? So we're tweaking with the window like this, and then we're going to hit graph. And here's my function. We graphed it. I don't expect you to do this by hand. I don't expect you to go bananas on it. I just need you to actually graph it, okay? So it kind of looks like this, right? They want the domain, and they want the range. Please remember, I just erased the board, but domain stands for x. Where does your x start? It starts at 0. So it's an x and a y. We know that far. It starts at 0. It keeps increasing. So my domain is x is greater or equal to 0. They could go 0 hours or they could go a million hours, right? Let's talk about y. Where does my y start? Again, this is a real life problem. It starts at 0, 0, right? And then what happens to my y? Look at this. It keeps growing. Greater or equal to 0. If they fly 0 hours, they don't move anywhere. They stay on the ground, right? Now they want to know, did they beat the record? Well, they say that they traveled, my t is 478 hours. Well, this is just a calculator problem, right? I'm going to go second, quit, and come back out here, and I go 97.8 times 478. And it's 46,748.4. It is clearly way bigger than the record, so yes, they did set the record. On B, it says graph the function. We already did, remember? You can go right back to your graph. It's right there. And then they say, use the graph to approximate how long it took them to travel 20,000 kilometers. If you look at that, you will immediately notice that we have a problem with our window, because our y is set at 10,000. We need to set that at 20,000, or let's set it at 30,000, right? So I'm going to go back to my window, and for my y maximum, I'm going to set 30,000. That's the only thing I'm going to change, nothing else. And then I hit graph again. This is my graph now. It's the same graph, but now my y is longer. I need to find out what is x when y is 20,000. So I'm going to hit trace. Okay, I have a dot over there, and I'm going to start moving it so you can see it where it is. My y right now is huge. It's 50,000 something, right? I need to bring it down to, let me see where I move it. Here it is. I need my y, so I'm going to use my right arrow, I'm sorry. And I'm going to make my y 20,000 and see what I get for my x. If you look at this, the closest I can get is y equals 20,808. My x is 212. So approximately 200 hours if I would have to fully approximate until they get to 20,000 kilometers. How did I do this? Again, trace, and then you move left and right. They give you the y, so you have to watch for your y to be 20,000 kilometers, and then you get to read your x. And that's about 2.1. I hope this helped. Happy homework.